Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are going to talk about fifth grade math. Excuse me. We are going to add decimals, and in this particular case, we are going to take a look at the Eureka Math Module 1, Lesson 9. We're adding decimals using place value strategies, and we're going to relate those strategies to a written method. So ideally what they want you to do is just to decode what's happening here. Ideally what they want you to do is they want you to go from word form to number form and then be able to apply the information that you've learned from word form with adding to the number form to adding decimals. So before we get started with any of this stuff, I want to make sure that we're super clear. Anytime we're adding a certain amount of things, it sometimes might be easier to stack things, okay? So that when you stack those things, you're kind of looking at it and you're saying like, oh, this is the place value. This is kind of what I'm looking for. And then the other thing that I want to mention is we can always replace the words like tenths and hundredths and thousands just to give us like a better understanding of what's happening with something like apples and dogs and bananas, right? So for example, 1/10 plus two more tenths could be one apple plus two more apples. And then that kind of makes sense to us. So we know we're going to end up with three apples, right? And so this is the, oh, whoops, just kidding. Oh, wrong thing. Okay, here we go. So we know that when we add 1 plus 2, we get 3. And then we know that this tenth and tenths, it's kind of like the same term over and over again. Apple, apples, right? Tree, trees, whatever it is. So we would just write out 3 tenths. Now, sometimes when it comes to problems like this, right? So this will also be 3 hundredths, right? So there's not much changing. They also want you to go in and they want you to put it in as a decimal form. So one of the things that we want to make sure that we cover, actually before we go in and do that equal sign, we want to make sure that we cover place value. So if I were to write a number, and I'm going to try and do this sideways on my little board. Whoa. Okay, here we go. Here we go. So I know that I'm going to have the ones place. My goodness. The ones place. Then I'm going to have a decimal. Then I'm going to have the tens place, right? Oh, whoops, not tens. The tenths. Tenths. Then I'm going to have the hundredths. That looks so phenomenal. Then I'm going to have the thousandths. And all of these kind of like come in with this THS at the very end. What happens is I'll have a number like, 1.234. We want to make sure that we know what our place value is. Anything with this THS at the end, THS at the end, that's something that's going after the decimal point. Anything without that THS is going to go somewhere before the decimal point to the left of the decimal point, okay? So in this particular case, when we go back to the original problem set, we know that anything tenths, right? Anything hundredths is going to go 0. Okay. So if I have 3 tenths, I know I'm going to go 0.3 or 0.3, whatever your teacher prefers. I don't think it matters. Like when you're in the middle school and high school level, some teachers don't even require the 0 in the middle school and high school level. I think on the elementary school level, it does show up a lot more frequently. So if I have 3 tenths, I know I'm going to put a 3 into the tenths column. If I have 3 hundredths, I know I'm going to put a 3 into the hundredths column. And that's just kind of like where it's going to be placed. That's all. If I had 3 thousandths, I would end up with 0, 0, and then the 3, because that's the column that it's going into. Okay. So assuming that we're on the same page here, this would just be 0.3. and this would just be 0.03. Okay. So now let's go back and let's take a look at this 14 tenths and 9 tenths. So I know that I can't have two numbers in one column. It just doesn't exist. There's not enough space for it, right? So if I had 14 tenths, then that would mean I have one whole, right? And 4 more tenths. So if I were to rewrite this as an actual number, that would end up as 1.4 plus the 9 tenths would be 0.9. Now, another thing that I want to make sure that we're on the same page with is that 14 plus 9 is 23. So I know that if I had 14 apples plus 9 more apples, I would end up with the same 23 apples. Oops, not apples, Anna. We want tenths here. Okay, right? Because we're just taking the type of term, the item that we're adding. We're just boom, 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 continuing with that same process, right? So in here, just 23 tenths cannot possibly be left as 23 tenths because I can't put the 2 and the 3 in the 10th column. So I'm going to leave it. I'm going to turn it into this 2 ones and 3 tenths, right? Even if I were to put in 23 tenths kind of in a fraction format, right? I would end up with 23 over 10. And I can change that into from an improper fraction to a mixed number as 2 wholes and 3 more tenths. So this is kind of like all the same business. This 2 wholes and 3 tenths. That's kind of where we're looking for, what we're looking for. Okay. So this would be kind of like my double answer, not just in word form, but in number form as well. Okay. Let's take a look at this bottom one right here. So I know that 27, and I see that they're both hundredths. So they're both this TH, I forgot a D over here, this THS, right? So I know they're the same kind of terms, right? 27 apples plus 5 more apples, right? So I get 32 apples. So in this case, I'm going to end up with 32 hundredths. I didn't make the same mistake again. And look at me forgetting this D every single time. Not every single time, but multiple times. Guess I'm a fabulous speller. So this 32 hundredths is kind of what we're looking for. But again, I know that 5 hundredths is the same thing as 0.05 because we start with a decimal point, then we go tenths, hundredths. And then I know that I have this 27 hundredths. Well, that's simple because that's just the same business, except instead of the 0, I now have this 2 tenths, right? 2 hundredths. So in here, if I were to rewrite the 32 hundredths, I would end up with 0.32, and 2 would be in that hundredths place, right? So in order for me to rewrite this as maybe in different format, I would say that I have maybe 3 tenths and 2 hundredths. Whoops, I just don't like this D here, apparently. Let's just change the way words are spelled. Oh my gosh. Okay, so there are other problems in the problem set that is in this homework assignment, but I'm not going to go ahead and do all of them because it might just turn into like a 40-minute video and nobody needs that in their life. So the next set of problems comes in with solving using the algorithm. So when we solve using an algorithm, ideally what we're doing is we're stacking things in the same bit, in the same sort of place value chart is what I'm looking for. Now, sometimes I know, and I of course don't have any like actual lined paper. Actually, JK, I have a notebook. So I want to make sure that we're in the same page so that you can see kind of what's happening. Most notebooks look like this. You have like your spiral, your holes, or like a plain piece of paper, right? So ideally, we're not using a plain piece of paper like this. We're actually using the paper going this way. So what's happening is I have this red line now on top. Oops. And then I have these light blue lines going kind of up and down. And so what I'm really doing is, oops, oh my, okay, there we go. And what I'm really doing is I'm putting these numbers in here so that I can add them a little easier. So I'm going to end up with 0.3 plus 0.82. And what I want is my decimals lined up in the same line, on that same blue line. And that's going to make my life easier when I add, because if I have a number in one of these numbers here, like an actual digit, and not in the other, I can replace that with this, like what I like to call sad zero. So these sad zeros, they have no value. They don't change the number. 3/10 is the same thing as 30 hundredths, right? Like I can see that this is 30 cents, and I can also see that 0.3 is also going to be 3 out of 10 cents, right? Which is the same thing as 30 out of 100 cents. So these are called sad zeros. They have no value. They cry all day. It's just a part of life, you know? So with these sad zeros, the reason why they're helpful is that I now know I have 0 plus 2 is 2, 8 plus 3 is 11. I can either bring the 1 up here because I know I can, and sometimes it might make more sense to bring it up there. But in this case, because these are both zeros, I can just leave it down there, no problem. But either or works. And then now when I add and subtract, even when I subtract with decimals, I know I'm going to have to line up that decimal point. So what's going to happen here is that decimal point is just going to line straight up and it's going to look beautiful. And then I'm going to have 1.12 or 1 whole and 12 hundredths. So what's happening is they want you to understand to go from this 10th, 3/10 plus 3 is plus 82 hundredths. They want you to be able to convert this into 30 hundredths and add 30 hundredths to 82 hundredths to get 1 whole and then some, okay? So I'm not going to keep doing this all over the place, but what I do want you to understand is that this decimal point and this decimal point need to kind of be one on top of the other in order for me to be able to add, okay? So now that they're one on top of the other, I actually know that in the answer, my decimal point will line up straight underneath. And because I don't have anything that I need to add, any sad zeros in here, I can just go straight to adding, right? So 8 plus 3 is 11, 1 on top, 1 on bottom. 1 plus 0 is 1, 1 plus 0 is 1. So my answer for this is 1.11. Again, let's try this again. So if I were to like rewrite this with actual numbers, this would be 7 ones and 3/10 plus 2 ones and 8/10. I guess they really like 8/10 and 3/10 or hundredths, I guess. There's some other problems. So 3 plus 8/10 is 11/10. Now we did say that we really don't have space for two numbers in one place category. So I am going to have to change this around, but I do want to make sure that we're on the same page with 3 plus 8 is 11. Okay, then I'm going to have 7 plus 2 is 9 ones. So I have 9 ones and 11/10. I can't simply go in and just say, hey, there's 9 ones and 11/10. I'm going to go in and show you how that change is going to happen. Whoops, that's not a 3, that's an 8. How that change is going to happen going from here to the actual final answer. So again, I lined up my decimals. I put those in. I put it in for the answer as well. I know that 3 plus 8 is 11. I'm going to bring 1 here and 1 up top, which means that this guy here, he's actually 1 whole. Or 1, 1, like Does that even make sense? I don't know. Would it make sense if I did that? It's like 1. I don't know. I feel like that doesn't make any sense. 1 whole. That was weird. 1 does just, I did not like that at all. Okay, so with that 1 up top, I now go in and I go, okay, 1 plus 7 plus 2 is going to be 10. And so my final answer is going to be 10.1. And in here, I'm going to see that because what happens is these 9 ones plus this 1 whole is going to give me 10 ones. And this 1/10 is going to stay as 1/10. So ta-da, here we are. Okay, let's go in and let's do that last one. Let me just change my ink color. Okay, so I know I have a decimal point here and I have a decimal point here. I'm going to go in straight with that decimal point right underneath so that I can go in and change whatever I need to change, move around different things. If I need to go in and add some more sad zeros, I can do that. But at least I know my decimal points are one above the other. I know directly to the right, I have a 0 and an 8. So I'm going to put 0 and 8. And directly to the left, I have a 2. So I'm going to put a 2. Now, I don't have to put a 0 there because I don't normally say 0 10s and 2 1s. And I also don't even need to put it in there because I can just add whole numbers a little bit differently than I can numbers after the decimal point. So I'm going to put in the decimal point in my answer right away. I have 3 plus 8. I feel like it's the same numbers over and over again. Don't know why the book does that, but it is what it is. So I've got 11. 7 plus 2 is 9. 5 plus nothing is 5. And that's going to be my answer. So that's it for using the algorithm. The most important thing is that we're making sure we're lining up the decimal when we add and subtract. Okay, let's take a look at this word problem that's in the problem set. So Van Cortland's Park. It's funny because all of these are New York City parks, and Marine Park and Central Park I've been to, but I've never been to Van Cortland Park. So I wonder where that might be. Okay, so Van Cortland's Park Trail is this many kilometers longer than Marine. So if something is longer than Marine Park, right, it's going to be more than 1.02 kilometers, 1 200ths of a kilometer. Then we know Central Park's walking trail is this many kilometers longer than Van Cortland's. So if we were going to put in just like from least to greatest, the parks, right? We know that Central Park is bigger than Van Cortland and Van Cortland is bigger than Marine Park, right? So let's put in Central Park is bigger than Van Cortland Park, I guess. And then Van Cortland Park is bigger than Marine Park. So if we are told that Marine Park, actually, I should have written that down somewhere. It is in the problem. In the problem, they give you a whole table, but I don't, I don't subscribe to tables. I guess maybe I don't. Maybe I do. Who knows? Okay. So Van Cortland's Park is bigger by this much than Marine Park. So I'm going to go in and I'm going to say, okay, here is my Marine Park, and I'm going to add this much to get my Van Cortland. So 8 plus 2. Again, I have to make sure I'm lining the decimals up. This time it works out because it's all three digits, right? So it works out beautifully. I just put one on top of the other, not a problem. 8 plus 2 is 10. 1 plus 2 is 3. 1 plus 1 is 2. So then I know that Van Cortland's Park, whoops, is not 1. It is 2.30 kilometers, or 2 3/10 of a kilometer. You could leave this 0 out because it is a sad 0. It has no value. It cries all day long. Or you could put it in. I don't think it matters, but there are some teachers who really have preferences, and so you want to make sure that you're following your teacher preferences as well. Okay, so now we know that Central Park's walking trail is longer than Van Cortland's walking trail. So we can just take Van Cortland's walking trail, which is 2.30, and add this number here. So I'm going to go ahead and make sure that my decimals are fully lined up. And in here, you can tell that you do need that sad zero. That was a weird looking sad thing. And then this is also a sad zero. So we're fine to put in as many as we want, as many as we need, so long as they're behind the decimal point, behind all the digits. Okay, 0 plus 2 is 2, 0 plus 4 is 4, 3 plus 2 is 5, 2 plus 0 is 2. So now I know that, whoops, Central Park is this many kilometers. Okay. So now it's asking me to go in and what would happen if a tourist, such as yourself or myself at this point, because I haven't lived in New York in a long time, if a tourist walked all 3 trails in one day, right? So all 3 trails means I would have to add all 3 of those items together. Now, one of the things that I can do is I can just go in and add 2 and then add the third one. I think that might make your life a little bit easier so that you're not looking at 3 different numbers. But if you like looking at 3 different numbers, I would probably start with the number with the most digits, go in and put in the next number that's lower and lower. I would put in some sad zeros here, assuming that this is one of your very first times working with adding decimals. If it's not, they are not absolutely necessary, okay? Because you know that if they're not there, you're just bringing that 2 down, right? 2 plus 0 is just 2. 8 plus 4 is 12. We're bringing that 1 up. And then I have 5 plus 3 plus 2. Oh, I forgot the 1. So that's going to be 11 plus 2 plus 2 plus 1 plus 1 is going to be 6. So now if I'm a tourist, how many kilometers would I walk if I walked all 3 trails? 6 kilometers and 122,000 of a kilometer. One thing that I do want to make sure that you're doing when you are solving these problems is that you are labeling them with the proper units. So if you didn't put kilometers, maybe you forgot, I would go back and change that. Make sure that you put kilometers in. Okay. I hope this was super helpful and I will see you in another video. Bye.